Open session. Any questions that you have for any of the panelists or in common, please feel free to get started. Yes, please.
I have one question, please.
Hello. Maybe the panelists can be seated also. That's okay. But I have one quick question to Debashish. You mentioned about the challenges in the underground assets. Are you talking of only underground pipelines or any other assets are there? And what is the challenge in underground pipelines?
Sir, primarily underground assets are normally pipelines. There are, if you put it in the scale of 1 to 10, normally 9 will be pipelines, 1 will be drums. Drums will be there. Like for example, our CBD closed blowdown drums and other things, this will be there. And the challenges we face is normally, see, these underground lines are protection is only cathodic corrosion has recently coming, but wrapping coating only is normally done. Different type of wrapping coating is there. First line painting, then you put 3P wraps, and several type of wraps has come. But how to know where the defects over the years of time, there could be a place where defect takes place. How do we know that? See, for the cross-country pipelines for our ONGC friends and all, there are techniques to check that. For that is only 1 line, 2 line, we exactly know the path and all. But inside a plant, where there is a configuration is different. Small, different sizes, 2 inch, 4 inch, 8 inch underground sections, like our closed blowdown drum connected pipings are 2 inch, 3 inch pipings. How do we check those? For that, we can't dig up the entire plant to check this. Those are the challenges. So our big pipelines, we have got tracer survey methods or several methods. But plant piping, how to do that? Because everywhere we cannot put tracer survey like radioactive things to check. Those are the practical challenges I was talking.
What we recommended for any concrete put at the most suitable?
Sir, practically speaking, in the plant, what we do, an inspector knows normally, the inspector assigned normally talks to that vessel or piping. He has got such a relation, every day he moves around. What he does, he checks from outside, he sees some oozing outside, reddish mark. He starts cleaning and he tries to find out something will be there. Now otherwise, how it suddenly changed his face, why it is reddish. There will be some refractory cement lining damage, and slowly salt water, any water comes in and corrodes from inside. These are the very methods practically we use. Otherwise, cement line piping inspection is little tough. Everywhere we cannot use tracer survey. It is not practical and even time consuming.
Any NDT available right now for those kinds of inspection?
If it is a large, like in our refinery, 36 inch lines is there. For that we do. For that we do put a tracer there to find it out. But plant inside have 3 inch, 6 inch piping and with different configurations. We cannot do all these. So we have to check simple visual inspection methods and suspect where are the problems could be. Normally problem comes in the joints when there are collars. Because collars, joining methods are very important at the time of inception. That in refinery over the times we have modified to several type of collars. We put sodium silicate joints, then we do welding, it bubbles up and fills the, then we put a collar. But typically, I don't know whether any Yale friends here, normally in projects, what they do, they just put it on and put one collar and weld it, and eventually it fails. So during our emenda, we do all those rectifications. Those are the way we inspect.
Okay.
I have a question for Dr. Krishnan, Ajay Krishnan, sorry. Actually, the question arises because your presentation showed a big dream, but your presentation also was pretty small. So, but one question arises from there is like you said you are going for modeling because the basic objective of that. And essentially it has to be empirical modeling. We said physics-based modeling, empirical modeling. Now, when you are modeling those, are you considering the geometry of your asset? Because if you go by the simple empirical formulation, it gives certain parameter, right? And putting an equation gives you certain rate. But say suppose a piping is geometry, variation of the insulation thickness, slope, are you considering that? Because the phase change there is a changes of phase, and the change of phase is changes of damage. So are you considering that?
To talk about this, so I'll not talk about the external one. Of course, external it's already covered. For internal, yes, you can do it. So if you want to take up any geometry, if it's there is a 90-degree bend, there is different kinds of bends. Then if you have a weld protrusion, then if you have any, as you said, there is if a multi-phase flow is happening inside, there's a water dropout or other things that are going to drop out. It's possible to model. It's whatever be the conditions. Like even if you're starting with, for example, I did a inspection in 2019 and I have measured a certain thickness, and now for the next 3-4 years I'm going to use certain crude assays. I'm giving an example. I can put in the properties, I can correlate this could be my corrosion rate, and I can schedule my inspections for the next future as well. We can model to that extent.
Is it only related to crude asset or your operating condition?
Yeah,
see, suppose crude asset and the column operating condition are interrelated.
Yeah, absolutely. So you can. That's why the integration with your DCS come in. So you can, of course, integrate DCS with your. I gave it as an example. You can do. It's up to your imagination that the way that you wanted to do it, but it's possible to do.
No, just last question: are you facing difficulties in integrating those things? I can do, that's fine. But are you facing to get a realistic data?
See, of course, that's where I wanted to start with. Like, you need to start somewhere. You have, if we think that we'll have these difficulties, we might not even take this initiative. So you can start, you can see how much of a correlation you will get from how much of, then you can move on. So maybe you can develop over the period of time.
Yeah, that's great.
Good evening all. My name is Piyush Arya. My question is, anybody can answer if... Yeah. No, it is not like that. But I have been hearing that this RLA, FFS, right? So, how many set of data is actually required for a proper RLA or FFS?
Yeah, thank you.
I know that Paresh sir will give the answer, but...
No, thank you. This is a good question. See, you have to understand, life is always correlated with design of any component. And design is done by the construction code. So construction code has the acceptance criteria for defects. So life assessment, if you find defects above that, you go for repair because you want it to be like original. But fitness for service is something where it teaches you living with the defect. So when you want to live with the defect, then you have to qualify the defect. So what happened that when these kind of industries started being manufactured, and especially the fabrication started, NDT was not so strong. And today, if you give this equipment, which was inspected 40 years before, and if you today inspect with Dr. Krishnan's technology, you will find many flaws which are not acceptable as per the construction code. So you are in a fix. You cannot run the equipment because you are bound by legal laws. So fitness for service has given you a ability to qualify those defects which is already running for 40 years, to quantify it so that if it reaches this size, you will leave it. So RLA is one where you are allowed to go on a highway at 80 speed. Fitness for service in an emergency will allow you to go at 120 speed.
And my next question is that for the process pipings, right? This you can say that health assessment is always a big challenge.
Yes.
Correct? Because of its complexity, sometimes change of phase, sometimes this accessibility also. So and this along with this underground that inspection, or you can say ki health assessment of underground piping is always a big challenge. I'm just trying to find out a suitable you can say methodology which I can get
Yeah.
the health assessment of underground piping.
See, what you should do is you should utilize the modern technology in terms of finding the probable areas of damage. Now, it is possible today that what is the risk of my pipeline from one end to another end, and then the critical locations, either you can open it from the ground and inspect it physically from external side, or you can put PIG, which is today's modern technology, without opening anything, and you can record the data. These are the two things which you can do for the effective inspection. Anybody can answer this.
We will do in our plants because they may not be pickable also. The
Yes.
kind of
That was
CBD
my
whatever. Use.
Yes.
So we take dig up pits while running the unit also we get permit. So we open, expose it and then check the health at different points. Let us say 10 meters, 6 meters. We take sample pits. We actually expose them and take measurements.
No, but that will also be, you can say that it will be a point based, or it will be a
No.
sample methodology.
Yeah, sample only, but at that location we do grid method. More sample points will be taken.
No, that is okay, sir.
More
I know that.
rather than a point location or at 3 locations.
So please.
Sir, actually, Paresh as well as Somsundar sir, as rightly said, we have to have a strategy of that. Strategy starts with a PNID of that, line route. And then we have to see the depth, what is the cover, soil cover. Whether any vehicles has traveled through that. Because if it is more than 1.1 meter, it is likely to not get damaged. If it is less than that, we normally put a hump there so that it doesn't get. Normally, wrapping coating gets damaged on external force only. Otherwise, I tell you one thing, underground transportation of petroleum gas is the safest.
Super.
That is the safest way of transporting anything other than overground. But electromagnetic. That electromagnetic, where the grid is going. So that magnetic field also creates a problem. So, yeah. So thing is, cement line piping, ideal thing is you have to have a strategy. If it is critical, first criticality survey you have to do, which is critical, which is not critical. Not critical, you will leave it to fail. When it fails, we will take care. But what is critical, you have to have a strategy with respect to all these 6-7 parameters, and then do bell hole survey, which is the most practical way, jo sir bataya. Bell hole survey, digging the small place, identify road crossings. Normally, those are the places there is a problem. Now in our refineries, Vizag refinery especially, with the help of what we have done now, localized, we have done CP system.
Okay.
I have tell you now, it has done a wonder. Failure I have not seen. Localized CP system is simple. We put one anode bed, simple, any anode, like MMO to best hai, bahut acha hai. Otherwise, any anode we put, connect it to a junction box, another point connected to the pipeline. You might think there is no flange, current will pass anywhere. I tell you that section gets okay. Only thing you have to, every 2 years you have to replace that anode, whatever anode you have used. Based on that, you have to, if it is a MMO, it will go for 20 years. But if it is iron or simple zinc, it will go in 2 years. So you have to have a frequency of inspection based on the anode bed. Otherwise, simple just connect it to the pipe, connect it to the junction box, check if it is close to the soil resistivity. 0.7, if it is more than 0.72, you allow it, continue. So this is the most practical way of inspector. What inspection engineers, my colleagues are also here sitting, they will also vouch for it. This is a practical way of doing it. I trust I have.
So one question is that how do you set up an inspection? How do you set up an inspection mechanism for detection of fugitive leaks in refinery?
Sir, should I take? Sir, fugitive emission testing, there are two parts of it. One is through acoustics. Every refinery has got some standing orders we call, and quarterly we inspect with that acoustic. Any leaks around the gland. Normally gland se hota hai fugitive emission. Safety valve passing ho raha hai ki nahi. Those quarterly basis we check. Otherwise, what refinery nowadays has gone for, that I forgot that code, fugitive emission in the valves and all. I think API 574, Navneet, if I am correct, that number, that we go for that. That under inspection on that code, glands are not expected to fail, and we purchase glands for very reputed manufacturers, like 6 to 7 manufacturers are there. This is the way we fugitive emission we normally try to avoid failing, and in case it fails, then separate method. This is how we detect every quarterly inspection. Quarterly inspection, acoustic emission we do. That is a regular practice, because you can't see, you can't hear also. And while doing that, servicing or buying, we follow those standards. I think API 574, I think, if I am not forgotten. Also
Yeah.
MOEF here.
I am Sarangapani from NTPC. My question is to Mr. Patra, Mitra. Sorry. We have a typical challenge in our GRP pipelines where water is being underground pipelines. Lot of leakages are there, and leakage is because it's the land is not ours. It takes a lot of time to repair. So whether the phonon technique or any other suitable technique is there for detecting early warning, I mean, of the leakage.
Sir,
some advanced information.
If it's a cross-connectory pipeline, and also it's a very sensitive, critical pipeline, phonon is a good technique what we have used. There are issues with cost, because with Russia, certain issues is there, certain cost especially. But it is a established good technique. But the thing is, whether it will kill a mosquito with a sword.
No, but what I am saying is that whether any use case of water, I mean GRP pipelines or
Sir,
even with MS doesn't matter.
Sir,
with water.
GRP pipelines, I don't know, very long, very old maybe.
Yeah.
Nowadays, normally we are not going for GRP for underground piping.
Okay.
Normally nowadays. But if it is an earlier case, GRP normally issue is there will be holidays, and through holidays there will be moisture going based on monsoon that side.
Correct.
And that will go underneath and will cause corrosion. There is no doubt. Only way of one of the thing is phonon. Other of the thing, dig from one bell hole. Try to do LRUT, but LRUT, because of attenuation, it will not go far. But at least it will go at least 5 meters. There you put another bell hole.
But this is about 40 kilometers. I mean, this is totally from one point from the makeup line to the power plant, which is about 40 kilometers.
If it is that critical, you can try phonon or such equivalent technology.
Okay.
You can try.
Acoustic, what is your take on that acoustic?
Sir, acoustic emission technique, हम लोग vessels में तो किया है. It is a very useful technique. In fact, we are running one vessel with sort of a little bit of FFS, and then we have put the sensors, acoustic sensors, and running that plant, running that vessel. It is very useful. But 40 kilometers, you said, na? For 40 kilometers, I am not very comfortable about acoustics, because it has a lot of limitations.
Yes.
Especially what happens now, acoustics, lot of acoustics are around. If a tree also fall on that, acoustics will generate. Filtering out the actual, for that you have to have a constant. It will have a minimum, maybe, I don't know, time, maybe 3 months, 6 months to filter out the bad noises.
And establish the baseline.
We establish the baseline. So acoustic you can try, but that's expensive methods.
By the time all MS line will come, we are changing it.
Yeah, by that time that will come.
Okay.
Thank you, sir.
Thank you all, and thank you for all the panelists. It's been wonderful.
Yeah, thank you. I'd like to thank our chairman, sir, of this session, Professor Krishnan, for nicely conduct this session.